Boxes are specifically designed to safeguard the products they contain and to cater to the customer's requirements. Regulations and standards are put in place to ensure that the quality criteria are met, thereby guaranteeing that the contents of the boxes are delivered without any damage. The industry has established tests and testing procedures to maintain consistent quality and ensure the box's overall performance. In this module, we will explore the process of designing a box, including testing and regulations to ensure quality. Corrugated packaging is designed and manufactured to meet the specific requirements of its contents. The entire package is engineered to meet each customer's unique needs. In order to make certain boxes, the two ends of the box blank must be fastened together with tape, staples, or glue. The regular slotted container, or RSC, is the workhorse of shipping containers. Its use far surpasses any other form of corrugated container. This is a blank for an RSC. Two scores running in the machine direction have already been made by the corrugator. These scores crush the board slightly and create lines where the top and bottom flaps will fold. The distance between these two scores forms the depth of the finished box. 6 slots are made that form the flaps at the top and bottom. 4 scores are made in the cross direction where the sides will fold. The distance between the slots and scores indicates the length, width, and depth of the finished box. See the tab here. This will be the connection point that holds all 4 sides together, called the manufacturer's joint. The flutes run vertically along the depth of the box to take advantage of the strength of the corrugated board and impart the stacking strength and crush resistance required by most boxes. In order to bring the panels together to form a box, some sort of connection or joint must be made. This is where the tab or glue lap comes into play. When the box blanks are being folded, this tab contacts the other end of the blank. Most often, it receives beads of adhesive and the opposing panel is pressed against it. This places the glue lap inside the perimeter of the box so that it doesn't show from the outside and doesn't interfere with printing or label lamination. This forms a flat, tube-like structure called a knockdown box, or KD. The manufacturer's joint can be strengthened by increasing the width of the glue lap so that it overlaps the side panel more. Glue joints are the most common type of manufacturer's joint because they are quick and economical to make. They're also smooth and don't form catch points that can scratch products or cause personal injury to handlers. Another method of securing the manufacturer's joint is with metal staples called stitches. Stitch joints are normally used when the container is subjected to water. Water can soften and weaken some adhesives, so mechanical fasteners are needed. The downside of stitch joints is that if they break, they can cause catch points that can scratch products or injure handlers. They're not the best choice for food packaging because if they do break, the pieces can contaminate the contents. The third way to make a manufacturer's joint is with tape. Boxes with tape joints are typically made without the tab. The two ends of the box are brought together and a length of tape is applied that overlaps each of the two panels. Since there is no tab, the inside perimeter is smooth and well suited for close-fitting items. However, the taping process is slower and more costly than gluing. And since the tape is applied to the outside, it may interfere with some printing layouts. Plain paper tape can be used, but is only recommended up to certain gross weights. Reinforced tape with synthetic fibers provide good tensile strength and tear resistance and are required for heavier packages. The primary use for corrugated combined board is boxes. Boxes can be used to ship everything from apples to washing machines. Many box styles can be identified by a descriptive name, by an acronym based on that name, or by an international code number. Boxes are described by their dimensions, grade, flute, and style. Box dimensions are always the inside dimensions and stated in the order of length, width, and depth. Length is always the longer dimension of the open end. Width is narrower for some boxes like those that open on the end. The longest dimension may not be the length. The depth is always the measurement perpendicular to the length and width. Two resources with additional information are a carton-style resource by AICC, an interactive gallery of carton styles commonly used in the packaging industry, and the Fiberbox Association's Fiberbox Handbook, with more specific information and examples of different box styles. Of course, corrugated board can be made into things other than boxes. Corrugated is often manufactured into many shapes to aid in the protection of goods being shipped. Partitions and dividers can be made to separate fragile objects. Corner posts add both rigidity and extra protection, since the corners of containers are the most susceptible to damage. Top and bottom pads can add cushioning where more protection is needed. Corrugated pads can be strategically placed to not only add cushioning, but to secure an article in place and keep it from moving during shipment. Pads can also be used to separate layers of products. Shells and tubes can be provided that enclose individual items. They can be made from single-face or single-wall board and may be taped or merely wrapped around the product. Most pieces of internal packaging are designed specifically for the product being shipped. They are made to keep the item being shipped away from the outer walls of the container and held in place to prevent movement. Besides boxes, corrugated is also used to unitize loads. A slip sheet is a sheet of corrugated board that is placed under a unitized load instead of a pallet. This allows a special fork truck with wide flat blades to slide underneath the load before lifting. Corrugated board is especially well suited for the construction of merchandising displays. These structures are only limited by the imagination of the designer. Vivid colored graphics and eye-catching shapes grab the attention of customers, drawing them to individually packaged products on display. Both floor standing and countertop merchandise can be placed in the retail space for easy customer access. Often, the shipping box transforms into the display. The ability of corrugated to be printed, die-cut, and assembled easily makes these displays powerful sales tools. Bulk containers are generally defined as those that hold 20 cubic feet or more of loose product, also known as IBS or intermediate bulk containers. They're most often used to ship commodity-type products to other facilities for repackaging, for resale, or to be used as ingredients. Often these containers are placed onto wooden, plastic, or fiberboard skids so they can be moved with industrial fork trucks after they've been filled. Depending on the weight of the product, bulk containers can be made from double or triple wall board. However, some especially heavy loads are shipped in containers made from multiple layers of double and triple wall that have been laminated together for added strength, rigidity, and puncture resistance. Depending on the contents, the interior surface may have a special coating, or in many cases, a liner might be added. Shipping container regulations are crucial to ensure that the goods transported reach their destination safely and securely. Containers undergo rigorous testing and certification to ensure structural integrity and safety during transportation. The railway and trucking industries have dictated that certain standards for corrugated be used for shipping containers they carry as consignees. In North America, the carriers impose packaging rules in exchange for accepting damage liability for the articles they transport. These carriers are responsible for delivering goods without damage, so they have a vested interest in the quality and strength of shipping containers. The rules for shipping products in corrugated boxes by truck or rail are specified in two publications: the National Motor Freight Classification for trucks and the Uniform Freight Classification by rail. The International Organization for Standardization sets standards for shipping containers known as ISO standards. These standards outline the general requirements for container dimensions, strength, and markings. Packaging is subjected to various tests to assess structural strength and durability. This includes tests for stacking capacity, maximum payload capacity, lifting points, and resistance to environmental conditions such as moisture. Certain tests have been established to ensure the strength of the corrugated board used. A box manufacturer's or maker's certificate printed on the box details the testing procedure and results. Two testing methods are used: the Mullen burst test and the edge crush compression test. The first test to be established was the Mullen burst test. As its name implies, this test measures the burst strength of a material. Container board as well as finished corrugated board can be tested this way. The test equipment takes a sample clamped in place, and a hydraulically loaded rubber diaphragm inflates, pushing against the sample unit until it bursts. The resulting values are measured in pounds per square inch, or kilopascals. This test was the standard for many years. While a direct measure of the strength of the sample, it has limited value for design, since it's not directly related to the properties considered critical by the box user. High burst strength relates to the tensile strength of the material. Box users are more interested in compression strength, the force required to crush a box vertically, and stiffness. For example, a piece of cloth may have very high burst strength, but very little stiffness and no compression strength at all. Compression strength is referred to as stacking strength in the shipping and warehouse environment. It is a combination of ECT and stiffness. ECT testing uses a small 2-inch by 2-inch sample that's placed on edge with the flutes in the vertical position between the two platens of the compression tester. The upper platen is loaded with increasing downforce until the sample fails. The result is expressed in pounds of force per linear inch. Edge crush is a predictor of box compression for regular slotted containers, the most common box style used. There's a direct relationship between the results from an edge crush compression test and box compression strength. A simple equation, called the McKee formula, uses ECT results as one of the variables to estimate box compression strength. For the sheet plant, ECT is an important incoming quality assurance test for corrugated sheets to determine their suitability for use. Corrugated plants also find value in the results for sheets coming from the corrugator to the box-making operations. A box manufacturer's or maker's certificate, sometimes called a CERT stamp, is printed on the bottom of each box to be used for shipping, either by rail or truck, and must be present for the carrier to accept damage liability for shipment. Today, most shippers have elected to use ECT values. Relying solely on one system or the other has its limitations. These carrier specifications apply only to RSCs, but make no reference to how long the boxes will be in the warehouse, impacting their exposure to humidity or known distribution hazards. So in effect, these rules are only a starting point and don't form the sole basis for a total box design. Thank you for tuning in to watch Module 4, A Box's Journey Part 2, Box Design, Regulations, and Testing. After this module, you have now learned about box design, including structure and box styles, shipping regulations, certifications, and testing. We encourage you to spend more time on the other corrugated industry curriculum modules and additional files within this curriculum and on our website at www.careersincorrugated.com to learn more about the corrugated packaging industry. The International Corrugated Packaging Foundation's programs and services are designed to help students, graduates, and job seekers find rewarding, lifelong careers in corrugated.